Okay, in this video, we're going to set up our problem and sort of the code uh, to the partition problem, and we're gonna use a systematic approach. We're going to use the design principles from how to design programs and go from there. So we're going to write function signatures, write some comments, write test cases, and once we're done with that, we'll move on to actual coding. So let's go ahead and start. So we're given two examples here. So the function that we want to write, let's call it can partition. And what it does is it takes an array of natural numbers and it returns a Boolean. So as you can see from the example of 9, on line 9, we want to take an array in and we want to produce true if it can be partitioned into two things. And so one of the invariants that we have to keep is that we want only the input has to be natural numbers, and that means it's greater than or equal to 0. So we don't want negative numbers. Okay, so our purpose is produce true if the set of numbers can be partitioned into two subsets that have the same sum. Produce false otherwise. Okay, so we have our signature, we have the purpose of our function, and now let's write a stub. So the reason that we write a stub is so this way, when we write tests, we can make sure our tests are well formed. So stub. So let's define can partition, and it takes an array. And right now, because it's a stub, we're going to return false. Okay. So now let's write some unit tests. So unit tests are actually work as examples at the beginning because they help us think about our code and helps us our intuition. So examples in tests. So we have class suite, and it has to take the unit test library of Python, and so we have. So let's call this test for can partition, and we take self as an input, and then so when you're given tests for free, like in example 9 and example 12, you want to in line 12 you want to use those. So let's go ahead and make those tests. So 1, 5, 11, 5, and you want to produce true, and self dot set equal. We have 1, 5, 3, and we want to produce false because that cannot be partitioned into two separate sets. And let's come up with another example. So it's good to think about small cases and edge cases as other ways, things to test. So let's suppose we have an array of one element as our input. If we have an array of one element, then we can't partition it into two separate sets with the same sum, so that's false. Let's think about some other edge case. So suppose you have two elements, and in this case, they can't be partitioned into two separate separate equal subsets. Okay, so we can run can partition again, and let's find an example of 2 that can be partitioned into 2 separate subsets. So 1, 1 can, so that's true. And let's think of a more complex example. So one way to think of this example is sort of have like pre-build your sum and then work from there. So what I did was I sort of jerry-rigged this in the sense that I came up with an example and then I made it a test. So I was like, okay, let me make a sum of 40 for the whole array, and let me make it so it can be broken down into 2 sets of 20/20. So what I got was 11, 3, 7, 1. I put a 0 in here just to because it should work. So 5, 9, 2, 2, and this can be broken up into 2 sets of 20s. So that's true. So this is our test for test suite for can partition. And one thing that you'll note is that from our previous video, we talked about that whenever we were making a decision of whether to take a number, like so in line 9, if we were going to take the number 5 or not, the total target sum that we were trying to hit was changing too. So every time we made a decision, that affected the target sum. But if you look at our input function right now, we just have an array. We don't have an array and the target sum. And so you might be wondering why. The reason for this is that we have to do a little bit of pre-processing. Our input's just an array of natural numbers. We have to figure out what is the sum that we need to hit. So we're going to have to divide. We're going to have to figure that out, and then we're going to have to do some other things. Like if you look at our test, we see that if you have an array of size 1, you already know that you can't partition that into into 2 subsets, so you can return false. Also, if we look at the example on line 34, we see that you have 0, 1, and so the average of that subset is also half, 1/2, and since we're only dealing with natural numbers, there's no way you can have a 2 subsets that have 1/2 as their sum. So we're going to have to pre-process those issues, and then we have to go from there. But for right now, what we can do, since we have this, let's just go ahead and check if our can partition tests are well formed, and so this way, if when our tests do fail later, we know it was because we didn't type them in wrong. So if we run this, so we get error. Okay, so if we look at line 31, so can partition takes. Okay, so the mistake I made here is actually in all of these tests, which is a good example, is that I wasn't careful about the commas. So can partition takes 1 argument, and then this cert equal takes 2 arguments. So this should be on the other side in all of these. So because we're comparing, so in line 31, we're comparing true to the result of can partition of an array. So let's fix that real quick. So this is another reason that you write a stub, because there's always a chance that you'll make small errors like this. And it's always good to be able to check that with the stub. Okay, so we fixed that. Let's run our test again. Okay, so now it seems like our test, if we look here, are failing because it seems to be because the stub is producing false and some of these tests are producing true. So so that seems like we're on the right track. And now we can go ahead and look into building our boilerplate code for can partition and go from there.